Hello everyone. In this particular video, we will be discussing about the merge sort. So merge sort is a sorting algorithm which is based on divide and conquer technique. So in merge sort, what we do is we divide the given list of numbers into separate sublists and we keep on dividing them until we have multiple lists containing one element each. And later we sort the elements and simultaneously combine them into the sorted list. So let us see how merge sort is performed. Over here we have a list of numbers and we need to sort them using the merge sort. So firstly, what we will do is we will divide the list of numbers into two parts. Since in this list we have 7 numbers, so I can divide it into two lists containing 4 and 3 elements each. So this is how I divide the list. Now I have two lists, and what I'll do is I will further divide the list into subparts. So the first list gets divided into two lists containing 4 2 and 7 3 respectively. And the second list, since it has odd number of elements, I get a list containing 6 1 and another list will contain only one element, that is 5. So I need to further divide these lists into subparts. So dividing the list further, here we go. Now I have multiple lists containing one elements each. So for the next part, what I need to do is I need to recombine the sublist to get a merged list containing the elements in sorted order. So if I take these two elements, for these two numbers, I need to recombine them and sort them into ascending order. So what will happen is 2 will come first and 4 will come after that. So like this, I'll repeat this for all the sublists and I will get the result as 2 4. Again, 7 and 3 will be combined in sorted order as 3 7 and 6 1 will be recombined as 1 6. Now what I need to do is I need to recombine these two lists and this list with this list. So to recombine the list containing multiple elements, what I'll do is I will compare the leftmost element of the first list with the leftmost element of the next list. So I will compare 2 and 3. Since 2 is smaller than 3, so the first element in the combined list will be 2. Now what I need to do is, since I have already taken 2, so I will cancel this out. Now to get the next element, I will again compare the leftmost element of the first list with the leftmost element of the next list. So the leftmost element of the left list will be 4 because 2 we have already considered. So the leftmost element will be 4. I will compare 4 with 3. Since 3 is smaller than 4, so I will write 3 and I will strike that out. Now I will compare 4 with 7. Since 4 is smaller than 7, I will take 4. Now, since only one element is left in the rightmost list, so I will write it as it is. So this should be the sorted list. Again, if I compare the list of 1, 6 and 5, I will compare the leftmost element of the left list with the leftmost element of the right list. So I will compare 1 with 5. Since 1 is smaller than 5, I will write 1 and now I will strike that out. Now I'll compare 6 with 5. Since 5 is smaller than 6, I will write 5 and strike it out. Since I'm left with only one element, I will write 6 as it is. So the combined list will be 2, 3, 4, 7 and 1, 5, 6. I will remove this for now. Now I'm left with two lists which I need to combine to get my sorted list of numbers. Again, I will follow the same thing. I will compare the leftmost element of the left list with the leftmost element of the right list. On comparing 2 with 1, we'll see that 1 is smaller than 2. So I will write 1 in the merged list and I'll strike it out. Now I will compare the leftmost element of the left list with the leftmost element of the right list. Again, on comparing 2 with 5, I'll see that 2 is smaller than 5. So I'll write 2 and strike it out. And then I'll compare 3 with 5. Since 3 is smaller than 5, So I'll write 3. Now I'll compare 4 with 5. Again, since 4 is smaller than 5, I'll write 4 and strike it out. Now I'll compare 7 with 5. Now since 5 is smaller than 7, I'll write 5. And then finally I'll compare 7 with 6. Since 6 is smaller than 7, I'll write 6. Now since only one element is left, I'll write that number as it is. So if we see the result, here we go. I got a sorted list containing the numbers in the sorted order. So this is how the merge sort works. Now let us see the Python implementation for the same. So this is the basic Python program to perform merge sort. In this, what I've done is I have defined a function named merge sort and I have passed the list of numbers that I need to sort. Inside this function, at first what I'm doing is I'm finding out the middle element by performing the floor division of the length of the list. After finding out the middle element, I will divide the list into two parts, that is the left half and the right half. The left half will contain the numbers starting from the 0th index location to the element before the middle element, and the right half will contain the numbers starting from the middle number until the last element in the list. So using this part of the code, I am dividing the list into two parts. Now, since I need to further divide the left half and the right half list, therefore, I am calling the merge sort function again for the left half and then for the right half respectively. So this will divide the list until we have just one element left in each list. Now what I'm doing is I'm declaring three variables I, j and k. The variable I will point to the leftmost element of the left list or the left half. The variable j will point to the leftmost element of the right half, and the variable k will be the pointer to the merged or the combined list. Initially, I'm assigning all of them as 0. Now, since my list is already divided, I need to recombine the divided list. So here we have a while loop which we are using to traverse both the left half and the right half of the list. If the leftmost element of the left half is smaller than the leftmost element of the right half, in that case, since the number in the left half list is smaller, I will insert that number in the merged or the sorted part of the list, and then I will increment the value of the pointer to the left half list. But if the right half of the list is smaller than the left half, in that case I will insert the element present in the right half list into the sorted list, and I will increment the pointer to the right list by 1. And then after every iteration or after every insertion, I will increment the value of k by 1. Here k, as we discussed, is the pointer to the merged or the sorted list. Now there could be a scenario where after all the comparisons, there are still some elements left in either left or the right list. In that case, what I need to do is I need to insert those elements in there as it is order at the end of the sorted or the merged list. So for that, I'm using two while loops. The first while loop will cater to the condition where I, that is the pointer to the left half of the list, is smaller than the length of the left half of the list. In that case, we can conclude that there are still some elements left in the left half list. So I will use this loop to insert those elements in the sorted list. Again, the next while loop will do the same thing for the right half list. So this was the function that we declared for merge sort. To test this, I have declared a list of elements that I need to sort. I will pass this list in the merge sort function that we declared, and then I'll print the sorted list. Now let us run this program to check the results. Here we go. Over here we can see that the list that we declared has been sorted in ascending order. So this was the basic Python implementation for the merge sort. If you liked the video, please don't forget to hit the like button and subscribe the channel. Thank you.